It is my greatest honor and a pleasure to introduce our next speaker, Professor Janos Szebeni from the Semmelweis University. And Janos will talk about nanostructure and anaphylactic reactogenicity of the COVID-19 mRNA-LNP vaccine, new findings and concepts. Would you like to use, I can use this microphone.
Thank you, Marina. I'd like to thank Beat for giving me this opportunity to talk about our new findings and concepts regarding the nanostructure and anaphylactic reactivity of the COVID-19 mRNA-LNP vaccines. I will talk mainly about Comirnaty. In addressing the questions regarding the nanostructure of Comirnaty and acute anaphylactic reactivity, I'd like to talk about the current models for LNP, our DLS, AFM, cryo-TEM, methylamine uptake data, and our new model. Regarding the anaphylactic reactivity, I will show you symptoms, the prevalence, role of anti-PEG antibodies, complement activation in the reactions, talk about pro-inflammatory cytokines, human and pig studies. But as you can see, this is quite a big program. It would take hours to talk about all these. So what I decided to do is to start with the conclusions. At least you can see what I'd like to tell you about. I know myself, and I am unable to reach usually the end of my presentation, so it's better that you see what I'd like to talk about. So the currently known LNP models are not applicable to mRNA-LNP vaccines for many reasons. Our thread ball model proposes partially bilayer covered nanoparticles with hydrogen bonds, stabilizing the mRNA lipid complex, which is in the core. Access of the vaccine to blood has short-term pro-inflammatory impact manifested in allergy symptoms and anaphylaxis. Complement activation, inflammatory cytokine upregulations may be contributing factors to anaphylaxis. Anti-PEG antibodies play a causal role in the acute allergic reactions. The porcine nanoparticle-induced anaphylactic shock model enables studying the allergic and inflammatory side effects of the vaccine. And most importantly, the intention is not to focus on the dark side or the bad things about the vaccine, but to help making it safer. So the conclusion is that much further research on the cellular molecular basis of the mRNA vaccine-induced adverse effects will improve safety, trust, and health policies. So now, the remaining of my time, I will give you glimpses into the experiments which we conducted and our ideas. So this is the currently available model for the vaccines. Actually, it was originally designed for siRNA containing LNPs, which, considering the fact that the mRNA in the vaccines is about 180 times bigger than the siRNA, these schemes, these cartoons are irrelevant. Here is a description of the different models. I wouldn't go into the details. In this publication, they are detailed. But in common, most cartoons show siRNA, as I mentioned. The mRNA localization and the interaction with lipids is ambiguous in the current models. And the outer membrane is also ambiguous. And the message is that it is not possible to use one model which would describe LNPs, these vaccine LNPs. Actually, each LNP requires its own model because of so much variation in the elements of the vaccine. In short, one size doesn't fit all. Now, these are our structural studies, AFM showing relatively homogeneous nanoparticles in the upper left. But looking at a sample after 1 day storage at 4 degrees, you see major disruption, which was also confirmed in the cryo-TEM images and the upper right 3 panels, which show that initially the nanoparticles are relatively identical, whereas 1 day after or later they fall apart. And the picture in the bottom middle is a very interesting one, because you don't see two identical, two similar nanoparticles. This was after storing them in water at 4 degrees. And here, there is no pointer, but in the middle picture, right bottom, you see even the exit of the mRNA from a nanoparticle. So in conclusion regarding these findings, the nanoparticles lose homogeneity within a day upon storage at 4 degrees. The nanoparticles are soft relative to other therapeutic lipids. I'm sorry, I forgot about mentioning the left bottom panel, which is an AFM study regarding the stiffness, the rigidity of the nanoparticles, and it established that these particles are very soft. Actually, there are some papers which call them liquid nanoparticles. They do not have a continuous mono and bilayer coating. The upper panels show it. The core is yarn ball-like supercoils. Here in the middle you can see. With strings of mRNA lipid hybrid double helices and nanolumps held together by hydrogen bonds. And the reason why I am talking about hydrogen bonds is due to the fact that turns out that the lipids in the nanoparticles, the cationic lipids, lose their positivity at the pH of physiological pH, yet the mRNA is held together held together. And it turns out that the positively charged lipids have a structure which fits very well to the mRNA basic chain. And closer analysis reveals that the O and OH groups are fitting to complement the mRNA with a chain, which we think is due to hydrogen bonds, and it stabilizes the mRNA inside the vesicles. The coat consists of polarized isolate. That is to say, the monolayers and bilayers are rendered into islet, one pole of the nanoparticle, and unfortunately the structure is prone for disintegration at 4 degrees, which explains a lot of the concerns about the clinical and preclinical studies before this vaccine was released. And we also believe that this structure is unique in nature because helix containing mRNA and lipid, we didn't find anything similar in biology textbooks. Regarding the adverse effects of COVID-19, there are a few are listed in the prescribing information, the package insert, but there are a lot further which are debated, which cause a lot of attention. And these are skin, cardiovascular, inflammatory, coagulation, nerve, autoimmune, even cancer problems. And obviously, there is no focused study which would set foot behind vaccines causing these side effects. But on the other hand, what we find, the pro-inflammatory action, short-term and long-term, is not inconsistent with these side effects. Regarding the anaphylaxis, its incidence was originally stated to be 5 to 315 per million, but later figures showed them in the order of hundreds, like 250, 400. And there is one Israeli study which states about 7,000 anaphylaxis in a million, but this study included only people with allergy. So it implies that people with allergy has an increased risk for anaphylaxis. By the way, at the moment, the CDC acknowledges one major side effect in 500. What we find is expired. Okay, so, well, maybe one more minute. What we find that people have anti-PEG antibodies in their blood, whose distribution is very unusual, highly left-screwed, and there are about 5% of people called anti-PEG antibody supercarriers who have extremely high levels over the median. And the next slide would show that our complement activation studies, which show that these people with high anti-PEG antibody levels have an increased capability for activating complement, which is consistent with the fact, another study I will show, that people who reacted had a higher, significantly higher anti-PEG antibody levels in their blood. This is the human study in which we compared anti-PEG antibodies in R, reactive, reactant, and non-reactant people. Look at the log scale. The difference is significant, both for IgG and IgM. These are the pig studies. In short, in pigs, in which we induce high levels of anti-PEG antibodies by immunization with pegylated liposomes. The antibody levels go orders of magnitude greater after about a week. And if we inject the pigs with the vaccine, then we see an anaphylactic reaction, a very strong reaction. You can see the vasoactivity, the drop of arterial pressure, rise of pulmonary arterial pressure. And what was a very surprising finding, that in the pigs, we had 6 pigs injected with the vaccine, and in these 6 pigs, the anti-PEG antibody levels were elevated due to the vaccination. All pigs died within 2 minutes. So an extremely strong anaphylactic reaction, which provides evidence that anti-PEG antibodies are playing a causal role in the reactions. These are the complement activation studies. I cannot go into details, but again, the conclusion is that anti-PEG antibodies are playing a role in this complement activation, and also the cytokine data. Very interestingly, we see cytokine upregulation, pro-inflammatory cytokine upregulation within minutes after administering the vaccine. And together with this, in parallel, the pro-inflammatory mRNA are upregulated, and after 6 hours, we even see the spike protein in the kidney as the immune histochemical staining shows. And so I don't need to repeat. I had this. I could reach the end. Thank you very much for that.
Thank you.